Hello dear students, welcome back to the video classes. Today this is the ninth lecture on the topic functions, that is types of functions and their problems. Today we are going to solve the few more examples from the exercise 1.2. Let me begin with the one more example, that is a function is the set of integers to the set of integer is given by f of x is equal to x cube. We have to check the given function is injective, surjective, or it is bijective. That is, the given function is 1 1, on 2 and bijective. To check the injectivity or 1 1, as we have seen in the previous class, we can check the function whether it is 1 1 or not. To check the 1 1 function, we have to check the given function is 1 1. To check the injectivity of the function for all x comma y belongs to z, consider f of x is equal to f of y. But our f of x is nothing but x cube and f of y is equal to y cube. By solving these two, we are getting x is equal to y. We are starting with f of x is equal to f of y, or we can say that f of x1 is equal to f of x2. Then that implies we can write x1 cube equal to x2 cube. We can prove that x1 and x2 both are equal. In this case, x and y both are equal. Therefore, the given function is injective, or it is 1 1. Now let me check whether the given function is onto or not. To check the surjectivity or onto, let me take one element, that is, for all y belongs to the codomain set, there exists x belongs to the domain set such that y is equal to f of x. Y is equal to, our f of x is nothing but x cube. Therefore, or this implies x is equal to cube root of y. There is no such element belongs to the set z. Therefore, this type of elements are not there in the integers. For all the values of y, there is no element x in the domain set z. Therefore, the given function is not surjective. It is not onto. Hence, the given function is only not onto. My dear students, therefore the given example f of x is equal to x cube is only 1 1 but not onto. Dear students, let me begin with the one more question. Let A is equal to a set containing 1 2 3, B is equal to, the elements are containing 4 5 6 7, and let F is equal to, it is a set containing the order pairs. The image of 1 is 4, the image of 2 is 5, the image of 3 is 6. Be a function defined from A to B, then you have to show that f is 1 1. Answer: it is given that A is a set 1 2, B is another set containing the elements 4, 5, 6, 7. F is a function defined from A to B as f of 1. The image of 1 in the codomain set is 4. The image of 2 is 5. The image of 3 is 6. The every element of A have the different images in B. Therefore, the given function is set to be and 1 1. That is, the image of 1 in under F is 4. The image of 2 under F is 5. The image of 3 under F is 6. Every element of the domain have the different images in a codomain. It is seen that the images of distinct element of A under F are distinct, hence the given function is 1 1. The given function is 1 1. This type of question will be expected in the examination for 1 or 2 marks. Moving to the next problem. Question number 7. In each of the following cases, state whether the function is 1 1, onto, or bijective, and we have to justify our answer. We have been given the question number 1. F from R to R defined by f of x is equal to 3 minus 4x. You have to check that the 3 minus 4x function is 1 1 and onto or not. Similarly, the another sub question in the same problem is given to you. F from R to R, set of real number to real number, is defined as f of x is equal to 1 plus x square. Here also we have to check the injectivity and surjectivity of both the problems. Dear students, let me begin with the first question. The answer for the first question: f is a function from R to R is defined as f of x is equal to 3 minus 4x. Now let me check the injective of the function is. You have to check the v1 function is 1 1 or not. For that, let me begin with, let x1 comma x2 belongs to R such that f of x1 is equal to f of x2. Our intention is to show that x1 and x2 both are equal. As we know that the f of x1 is nothing but 3 minus 4x1 is equal to f of x2 is 3 minus 4x2. Now we can eliminate 3 from either sides. We are left with minus 4x1 is equal to minus 4x2. Minus 4 cancels. We get x1 is equal to x2. Therefore, the function f is said to be 1 1. Therefore, the given function f of x is equal to 3 minus 4x is 1 1. Now let me check. Now, my dear students, we have to check whether the given function is and not. The given function is an onto or not. Our definition goes like this: for all y belongs to the domain. Domain is our set of real numbers. Codomain, y belongs to the codomain. There exists x belongs to the domain. Domain is also the set of real number such that y is equal to f of x. Y is equal to, our f of x is nothing but 3 minus 4x. In this case, we have to solve for x. Therefore, I can write 4x is equal to 3 minus y. By rearranging the equation, we can solve for 4x. 4x we can bring it to the left side and y to the right side. We get 4x is equal to 3 minus y. Therefore, x is equal to 3 minus y divided by 4. For any value of y, there is a value of x which is belongs to the domain set R. For every value of y, there is an x value belongs to the domain set R. Therefore, the given function is said to be an onto function. Therefore, the given function is both 1 1 as well as onto. Therefore, such functions are called bijective functions. Therefore, the given function f of x is equal to 3 minus 4x is both 1 1 and onto. Dear students, let me take the another question. F from R to R is defined as f of x is equal to 1 plus x square. Once again, we have to decide, we have to check whether the given function is 1 1 or onto or not. Let me begin with for 1 1. We have to check whether the given function is 1 1 or not. To check the injectivity of the function, we have to start with x1 comma x2 belongs to the domain R such that f of x1 is equal to f of x2. But our f of x is nothing but 1 plus x square. Therefore, x1 f of x1 is equal to 1 plus x1 square. Therefore, our left hand side is nothing but 1 plus x1 square is equal to the right hand side is 1 plus x2 square. By eliminating 1 from both the sides, 1 1 cancels, we will get x1 square is equal to x2 square. Let me solve for x1. x1 will be equal to plus or minus x2. Since the domain is the set of real numbers, therefore the positive and negative values of R are there in the domain set. Therefore x1 has two elements. One is plus x2 and another one is minus x2. Therefore we can say that f of x1 equal to f of x2 does not imply that x1 is equal to x2. Therefore the given function is not 1 1. The given function is not 1 1 because x1 has two images which does not satisfy for the 1 1 function. Dear students, now we will check for ontoness. We have to check whether the given function is an onto or not. To check the ontoness of the function, we have to check whether the given function is an onto or not. For all y belongs to the codomain set, there exists x belongs to R such that y is equal to f of x. Y is equal to our f of x is nothing but 1 plus x square. This implies that x square is equal to square root of x square is equal to y minus 1. Therefore x is equal to plus or minus square root of y minus 1. For different values of y, there is no element of x which is not belongs to the domain set. Therefore the given function is not an onto function. Dear students, here we are going to solve for x. For that case we can write x square is equal to y minus 1. Therefore x is equal to plus or minus y minus 1. For different values of y, there is no element of x in R. That's why the given function is not an onto function. Therefore the given function is neither 1 1 nor onto. My dear students, let me take the one more question number 8. Let capital A and capital B be sets. You have to show that f from A cross B to B cross A such that A comma B is equal to B comma A is bijective function. Dear students, you have to show that the given function is a bijective function. Dear students, let me begin with the solution of this problem. That is the answer of this question is f from A cross B to B cross A is defined as f of A comma B is equal to BA. Take the two elements in the because the given function is defined under order pairs A comma B. Let A1 comma B1 and A2 comma P2 belongs to A cross B such that f of A1 comma B1 is equal to f of A2 comma B2. As we know that f of A comma B is equal to BA, therefore f of A1 comma B1 will be B1 comma A1 and f of A2 comma B2 will be B2 comma A2. Since both the order pairs are equal, therefore the corresponding elements of both the order pairs are same. Therefore we can write B1 is equal to B2 and A1 is equal to A2. Therefore we can say that A1 B1 is equal to A2 B2. Therefore the given function is said to be an 1 1. Now my dear students, it is very easy to prove the given function is 1 1. Once this question was given in the examination for 3 marks. Dear students, let me check we check the ontoness of the function. Now let b comma a belongs to such that there exists a comma b belongs to a cross b, such that f of a comma b is equal to b. By definition of f is onto, hence the given function is said to be an what it is, bijective. Dear students, therefore the given function f from a cross b to b cross a, defined as f of a comma b is equal to b comma a, is a bijective function. I hope you have understood the today's class. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.